Hi guys, my name is Professor Steve, and today we're going to be going over flat Earth calculus, specifically how to apply Gauss's law to derive the thickness of our flat Earth. I want to show you my calculus textbook from my first year of university. I show this to you so that you know that I actually do know what I'm talking about and that this is going to be different from your typical flat Earth video. As a man of science myself, I am firmly rooted in all the laws of math and physics. Science and math is how we can confidently know the Earth is flat. So I hope you stay and watch this and try to understand it. There are 6 main points that I broke it down to. So if you can address those points in the comments when you make one, that'll make it easier for everyone to reference this whiteboard and kind of see what you're arguing about. Do you have a problem with the Gaussian surface? Do you have a problem with the integration? So let me know and we can work through this together. Gauss's law states that the gravitational flux over a closed surface is proportional to the enclosed mass. Now, mathematically, it's expressed as an integral. Now, this is really good for us because we're dealing with an infinite plane. That's one of the reasons why we use calculus. It allows us to solve quantities and deal with infinities. So right up here is what we're trying to represent. We have the infinite plane and we have that radius r. That's what we can determine. Essentially what we got is a uniform gravitational field. We're going to use a pillbox Gaussian surface. Now the reason why we do that is the formula is well known. So you can't really argue about this. Now it's expressed as a dr. So we're still dealing with calculus at this point, but we can apply Gauss's law right here on that infinite plane to get the conclusion that the gravitational acceleration is equal to 2 pi the gravitational constant times the surface mass density. So what does that mean? We can solve for the surface mass density and we end up getting a final answer right here. Now, the final part of this is the mass over an infinite plane. Again, this is another well-known formula. You can't really argue about it. So we're going to use the constants, the mass of Earth, the surface mass density, pi r2, and you solve for r and you get 9,000 kilometers. So what that means is this r right here, that is 9,000 kilometers, meaning the total thickness is 18,000 kilometers. If you want the downward vector of 9.8 meters per second, which you do because we want an accurate flat Earth model,